Good evening to all of you. Today we are going to start one of the most important part of chemical bonding. That part is considered as dimerization and polymerization. Actually, we can't say that polymerization is a topic of inorganic chemistry or organic chemistry. It is equally important in both the cases. So, this part actually deals with bridge bonding. What are the conditions? Bridge bonding is also known as, banana bonding or tau bonding because of its shape. There are many questions asked in JEE Advance depending on this topic. Let's start the topic and understand in detail. First, dimerization. What do you mean by dimerization? As the word signifies, see, dimer. Dimer means, di means two. Means two smaller units are getting connected to form one bigger unit. Let us consider when we are taking A plus A, two simple monomeric unit we are taking. They will combine with each other and they will form A2. As A2 formed, we name it as dimer. Let us consider more than 2, then what will we name? A plus A plus A. Here it forms A3. A3 is considered as trimer, as 3 atoms are connected and 1 molecule is formed. If 4 are connected, it will be named as tetramer. 5 connected, named as pentamer. Let us consider, I have taken n number of A atoms. They are connected with each other. They will form AN. AN is considered as polymer. This is polymeric unit. So dimer, trimer and polymer. We know that this polymerization. So how this polymerization will happen? If this is polymerization, how this will happen? We can say that polymerization, it happens through bridge bonding. This is our point of discussion. So how bridge bonding is formed? How can we imagine a molecule that is forming bridge bonding? Let us take an example. For example, it is given AB3 and it is asked, how can it be connected? Let's see. 1A is connected with 3B atoms. So for each A, there are 3B atoms connected. I am marking it as 1, 2 and 3. Another molecule, if I want to connect, I will take 1A connecting with B, 1 and 1. So this is 1, 2, or we can consider like 1, 2 and 3. In this case, 1B, second B and third B connected. In this way also, 1, 2 and 3. These two are common actually. There are more ways to connect as well. For example, someone can consider like A connected with 1B, another B, and in this case, it is connected with another B molecule like this. Or we can consider A that is connected in one side with B, another side with another B, and one B like this. So they both can make bond in this way as well. There are many ways to connect. But how bridge bonding can be explained? And which are the bridging atoms? These atoms, they are considered as bridge atoms. So they are bridge atoms. So is there any condition to form bridge bond? Yes, there is. And what are the conditions? Let's discuss the conditions one by one. So we are going to discuss conditions for formation of bridge bonding. So what are the conditions? First condition, whatever central atom you are taking, that should have vacant orbital. So the first criteria is vacant orbital should be present. Vacant orbital should be present. Where? On the central atom. So central atom should have vacant orbital. It is one criteria. What is another criteria? Another criteria is, back bonding. Back bonding also is one of the most important topic that is discussed in inorganic chemistry. So in case of back bonding, generally if back bonding is happening in a compound, then formation of bridge bond is little tough or it is not suitable. So another condition will take that tendency to form back bond should be low or less. What is back bonding? In the next lecture, in the next video you will get what is back bonding. I'll discuss in detail about back bonding. Let's take the another conditions. So which type of bonds are bridge bonding? We are going to discuss one by one. I think you have written all these things. So I am going in detail for the next part. What are bridge bonds? How many types are there? We are going to that. So in this case, we are going to take one by one. First I am going to take type 1. We can name it as X center Y electron system. It may be X center X electron system as well. But generally that form is very easy. I'll discuss that. This form generally people are confused. Let's see. First type I am taking. This is type 1. So in type 1 we are taking 3C 2E bond. That is, what is 3C means? 3 center. 2E means 2 electron. And 3 center 2 electron system we are discussing. 3 center means there should be 3 atoms behaving as a center. 2 electron means they are sharing 2 electron in between 3 center. But strange, how is it possible? 3 atoms are there, only 2 electrons are shared. How is it possible? Let's check. For example, we take the example of diborane. Diborane written as B2H6. How it comes? As we have read before, A plus A gives A2, that is a dimer. So, BH3 connecting with another BH3 unit produces B2H6. We can say that this is dimer of BH3. So, this is the dimer of BH3 molecule. Now, what is the hybridization and what is the name of the molecule? BH3 is named as borane. So name is borane. BH3 is named as borane. What is the hybridization of BH3? BH3 is sp2 hybridized. How can I say that it is sp2 hybridized? B connected with 3 atoms, 3 hydrogen atoms, 3 sigma bonds. So hybridization is sp2. What is the rule? Rule is number of sigma bond plus number of lone pair. This is the concept of hybridization. Here 3 atoms are there. This is sp2 hybridized. But we know that B2H6 is sp3 hybridized. So how is it possible? Let's check. B. It has atomic number 5 represented as 1s2, 2s2, 2p1. This is the valence shell. So in this case, we are generally confused in between shell, orbit, orbital. Basically, shell or energy level or orbit are same thing. K, L, M, N, they are considered as cell. Inside the cell, subshell exists. What are they? S, P, D, F, they are subshell. Inside the subshell, orbital exists. What are orbitals? S, Px, Py, Pz. They are considered as orbitals. So, in this case you can consider for 2s2, it is the arrangement, and in case of 2p1 arrangement is this, 2s2, 2p1. But it is the ground state of the atom. So in excited state, what happens? This electron jumps to p orbital. This is R2s and 2p orbital. When it jumps, what happens generally? 1s and p2. Hybridization becomes sp2. But whenever you take B2H6, it changes a little. Another B has also same configuration. So the field orbital is shared in between another BH3. As a result, their hybridization becomes 1s and 3p. For B2H6, configuration becomes sp3. So in case of B2H6 arrangement, we consider like this. Hydrogen generally makes sigma bond and it overlaps with 2 B units. As a result, its hybridization changes. If you want to check for B atoms, what are the possibilities, how they combine with each other? Let's check. For BH3, let us consider I am taking BH3. I am taking 2 BH3 units and connecting them. B connecting with these are the orbitals. Among them 3 are filled and 1 is vacant. We know octet is not filled. BH3 has 6 electrons in its outermost orbit. Hydrogen has s orbital. Hydrogen has 1 electron, it has 1 electron. So both are shared 2 electrons. Same happens here. And same happens here as well, BH3. Another BH3 unit we are taking, B. This is connecting with hydrogen, so 2 electrons. This is another one, BH3. So the combination can be drawn like this, and 1 vacant orbital. Why I am writing in this manner? Because they are p orbitals. P orbitals are vacant for B. That's why I have written like this. Hydrogen has s orbital, so drawn in circular pattern. So these are the basic sharing of electrons. So you can say with these bonds, they are being connected with B, central atom. Now, how can 3 center 2 electron bond can be shared? You can see over here. In this case, you can see here B and B is connected. If this B connected with this hydrogen and this B, then we will get 3 center and it already have 2 electrons. So let's draw it in a proper manner. So for diboron, we can find it out. In case of B, how many electrons are there for B? This is the arrangement of B. For another B, what is the arrangement? For another B arrangement in the same way, 1, 2, 3 and 4. For this also 4. All are arranged. In this case, you can check that hydrogen atoms are connected with it. Each are having one electron. Each atom having one electron. B has 1 electron in its orbit. It has 1 electron in its orbit. This B has also 1 electron. This has 1 electron. This has 1 electron. And this has 1 electron. One completely vacant orbital for B. What I am going to do? I am going to connect with hydrogen, and one electron comes from hydrogen when it is connected with it. So hydrogen, another one, hydrogen here giving another one, hydrogen here also giving another one. I am not drawing it because I am going to combine both. In this case, hydrogen is going to give another one, this one. Here also, hydrogen is going to give one electron like this. For Al2Cl6, what is the arrangement of the molecule? See, chlorine is an electron-rich species. One aluminium connected with two chlorine atoms. Another case, another chlorine, aluminium connected like this. You can see, chlorine is an electron-rich species. It has more amount of electrons, more lone pair is present, but hydrogen do not have that. It has only one electron in its outermost orbit. Both electrons are taken and two electrons it is becoming, but it has many electrons, 7 to be more appropriate. So it is sharing its one electron pair to aluminium. So this is 2, this is 2, total 4 electron is there, and 1, 2, 3. So this becomes 3 center 4 electron system. Same is happening here. This is also 3 center 4 electron system. But see this, in this case only 2 centers are there. One bond means 2 electron. 2 center 2 electron, 2 center 2 electron, 2 center 2 electron, 2 center 2 electron systems. So basically this compound has 2 3 center 4 electron and 4 2 center 2 electron systems. There is 3 center 3 electron system 0, or 3 center 2 electron system 0. Keep one thing in mind properly, that if 3C4E is coming, then 2C2E will come. If 3C2E is coming, then 2C2E will come. There will be no combination of 3C2E or 3C4E. In both the cases they cannot be together. These two can be together or these two can be together. So these are all type of X center Y electron systems we have discussed today. I hope you understand all the things. If you have any confusion regarding that topic, you can text in YouTube. And also if you want some more videos or any topic you have confusion, please type it in the chat box. I will reply to you obviously. Thank you everyone. Be connected, like and subscribe. In this case, you can see total 6 hydrogen and 2 B atoms are there. This electron pair is being shared between 2 B and H. So जो इलेक्ट्रॉन पेयर है, 2 बोरोन और 1 हाइड्रोजन के बीच शेयर हो रहा है. So total center बन गया 3. Total 3 centers are there. And total used electron is 2. That's why this one and this one becomes 3 center 2 electron system. So there are 2 3 center 2 electron systems. Now what about these side atoms, and what are the another way to represent them? We can see there is another way to represent them. What is that? It can be represented as B connected with one hydrogen, another hydrogen connected with B, and this is the format of representing them. These two structures are equivalent. So this is also named as a bridge bond or a banana bond or tau bond. Now the question is, why B2H6 is forming banana bonding? What is the logic behind it? What is the benefit of forming this bond? Let's check out. Before that, we'll understand about these bonds. See, in this case, only 2 atoms are there, 1 and 2. So there are 2 center. How many electrons? 1 and 2, 2 electrons. So this is 2 center 2 electron system. This is 2 center 2 electron system. This is 2 center 2 electron system. This is also 2 center 2 electron system. So in this case 4 2 center 2 electron system is present. So in banana bonding, 2 3 center 2 electron system and 4 2 center 2 electron systems are present. So is this clear? Okay. Now let's see why these bonds are formed like this. What is the logic behind forming these type of bonds? Let's see. B2H6 forming banana bonding, quite okay. 3 center 2 electron system present R2. 4 2 center 2 electron system, that is also okay. But what is the benefit? What is the benefit of formation of bond? We know whenever any bond is formed, the main logic is to decrease repulsion, increasing stability. Same thing happens here. In this case, we can say that to decrease repulsion, to decrease the repulsion between whom? Between repulsion between two bonds, between two bonds. Which two bonds? Between B and H bond. They stretch. They stretch a little bit upwards and little bit downwards, so that they can be stable in that position. In case of B2H6, it moves little bit upward and it moves little bit downwards. So they stretch a little for their stability. That's why this is known as banana bond or tau bond. What is the actual structure? Let's come to the actual structure. So the actual structure. What is the actual structure? Actual structure is, we can draw it like B. Another B is there. Which type of bonding is there? Banana bonding. It looks like this. It looks like banana. Here hydrogen is present. In this case also little stretch. Here also hydrogen is present. Another hydrogen connected like this. Another hydrogen connected like this. One hydrogen is like this. Another hydrogen is like this. Total 1, 2, 3, 4, 5, 6 hydrogens are there. So bridge bonds lie above the plane and below the plane. Why? To stretch a little, to give some extra stability to the molecule. So we can see this. This is the actual structure that is represented. Now, if I want to represent it in bond line format, how it can be drawn? It can be drawn like this. In bond line format, we can draw it like this. B connected with one hydrogen, connected with another hydrogen, another B connected with one hydrogen, connected with another hydrogen, and in this case one bond is above and one bond is below. So this is the representation. What are the angular representations? In between them, angle is near about 97 degree. The outside angle is 120 degree. And in this case, so terminal bonds, if we are talking about inside angles, their angles are smaller. Outward angles, they are bigger. Let's talk about the length. We can see this length is little bit stretched. As a result, these lengths are more in comparison with these lengths. If I mark it, these lengths as A, This is also A. These lengths are as B. So we can say that always A greater than B. If we are talking about length, so we can say that bridging lengths greater than normal bonds, or better to say bridging bonds greater than normal bonds. But about the angle, if we talk about, inner angles are smaller than the outer angles. So we can explain it like in terms of bond length and bond angle. We can comment. Bond angle is, regarding bond angle, we can say that terminal bond angle, it is greater than bridging bond angle. So this is the basic logic. Very famous question that is asked in Iitjee. It is asked how many atoms lie in the same plane. How many atoms lie in the same plane? You can check. 1, 2, 3, 4, 5, 6. So you can say that 6 atoms lie on the same plane. 6 atoms lie on the same plane. What is the behavior of the, how the compounds representation, or what is the structure of compound? Is it planar? Is it non-planar? Obviously it is non-planar in nature. Why? Because these two are, one is above the plane, one is below the plane. So this is a non-planar compound. This is a non-planar compound. We can comment like this. Let us take few more compounds and discuss about them. We will discuss about some monomeric units. Let's see. Regarding monomers, we will discuss. For example, very famous monomer, that is BeH2. If it is taken, how it is represented? Be bonded with hydrogen. This is sp hybridized, obviously linear structure. If we take dimer of BeH2, how it can be represented? It is represented as BeH2 whole 2. Now let's draw it. BeH2 whole 2 represented like this. 4 hydrogens, 2 Be, 1, 2, 3, 4. 4 hydrogens are there. Now let's see which type of bonds are these. This is 2 electron and 2 centers. So 2 center, 2 electron system. This is 2 center, 2 electron system. Hybridization, 3 atoms are there. So hybridization is sp2. This is also sp2 hybridized. In this case, 1, 2, 3. What is beryllium? What is the atomic number of beryllium? 4. So we can write 1s2, 2s2. So if 1s2, 2s2 in excited state, its p is vacant. So in this case, 1Be has vacant orbital. This can also be considered as, let us consider, this has 2 electrons. So this is 0 electron. In this case, this has 2 electrons. This is 0 electron. So we can say that 2 electrons are used in between them. So this is also a 3 center 2 electron system. This is also 3 center 2 electron system. So this is the general representation of the compounds. Now in this case, we take few more examples to explain the compounds. Let's take the polymeric unit of BeH2. If we take polymer, for the same compound, polymer is there. For the same compound, polymer is there. Let's take the polymeric unit. See, Be connected with hydrogens. Again it is connected with hydrogens. Again it is connected with hydrogens. Another representation can be like this. This is represented in this format. It is the polymeric unit. For each atom, you check the hybridization. 4 bonds, sp3. 4 bonds, sp3. 4 bonds, sp3. Number of sigma bonds. This compound is also non-planar. Here also 3 center 2 electron system, 3 center 2 electron system, 3 center 2 electron system, 3 center 2 electron system. The terminal bonds, they are 2 center 2 electron system. This is the general representation of B2H6. Understood? So coming to the next formats, some other compounds we will see. So basically we discussed about 3 center 2 electron, 2 center 2 electron, we already discussed. Now we will go to another examples, that is 4 center 2 electron system. Let's take an example. Very famous examples are there, and generally students got confused in that topics. So we'll check how we can make it easier. Let us consider, given AlH3, another compound given AlCl3. For AlH3, representation is like aluminium connected with 3 hydrogens. So it is actually Al2H6. So hydrogen connected with another hydrogen, hydrogen connected with another hydrogen, aluminium and connected with hydrogen, it is connected with another hydrogen atom. This is Al2H6. See, same logic like B2H6. 3 center 2 electron system, 3 center 2 electron system, same 6 atoms are on the plane, 2 are out of the plane, same logic is following. This is 2 center 2 electron system, this is 2 center 2 electron system, this is 2 center 2 electron system, 2 center 2 electron system. So simply 4 2 center 2 electron system and 2 3 center 2 electron system. But if you take AlCl3, we know chlorine is a electron rich species. Same it will form Al2Cl6. Thank you so much.